Good morning, good afternoon, good evening, wherever you are located, and welcome to the AMETEK Solid-State Controls webinar this month. And this month we are going to discuss why you should use an RMBS, or a remote manual bypass switch, or remote maintenance bypass switch. Both terms are interchangeable. What we're going to do is wait a few moments for everybody to get onto the webinar, and then we'll get started. While we wait, just want to explain, on the right-hand side, you should have a chat bar. If you can hear me, it would be appreciated if you could type in there and say, yes, you can hear me loud and clear, or if my volume is too low, or whatever you need to do. So we'll give it a few more moments before we get started. Thank you, everybody, for letting me know that you can hear me. Okay. So as some more people come in, I'll just introduce myself. My name is Craig Williams. I'm the Senior Technical Manager for AMETEK Solid-State Controls, and I'm based out of the Stafford office in Houston, Texas. I've been with AMETEK Solidstate Controls. This is my 4th year with the company, but I have 20 years in the industrial UPS industry. You can probably tell from my accent, I'm not from around these parts in Houston, Texas. I'm actually from Scotland originally. And I used to work in the North Sea oil and gas fields, installing, commissioning, and troubleshooting and repairing UPS systems in the North Sea and internationally. I've worked on all major UPS charger manufacturers, nearly all of them anyway. So I'm very familiar with all the different types and the different designs and the differences between most of the manufacturers. So hopefully I come to you with a significant amount of experience and skill to discuss this issue with you today. The platform we use is called Webinar Jam, and Webinar Jam has to convert this webinar to Android devices, iOS devices, and to Windows devices. So the processing time it takes for that is roughly about 15 seconds. So from the time I actually talk to the time that you hear me talk, there's about a 15-second delay. So therefore, there is about a 15-second delay from me saying something, you typing in a question, and then me seeing it in the chat bar. So what I tend to do is I try and leave all of the questions until the very end of the webinar. If I do notice something and it's very pertinent to what I'm talking at the time, then then I will try and address it. But in most cases, I will wait all the way until the end. Webinar Jam does have a panic button. You can't see it on your screen, but on my dashboard, if things go wrong, if the internet gets hung up, or I get a lot of people saying that you can't hear me or can't see something, then I can press the panic button, and that starts a new room. Everybody gets kicked out of the old room, and you get invited back into the new room, and we should carry on from where we left off. A very common question that we get on all of our webinars is, will it be recorded? And the answer is yes. Because you have registered, well, most people who are watching this live have obviously registered for the webinar, then you will get a link afterwards to go and rewatch the video at your pleasure. The thing about the webinar version of the video is you can't rewind, fast forward the video to the bits that you are interested in. It's treated like a brand new webinar. You've got to watch it from start to finish. But what our fantastic marketing department do is, within 24 hours of this webinar, they will convert the file to an MP4 file, and then they will upload it to our AMETEK Solid-State Controls website, a YouTube channel. So you can watch it, rewind it, pause it, do whatever you need to do. And they will send the link out to that at the end of this webinar. And the last thing is, the webinar should last around about an hour. Depends on how much I talk, which can get lengthy sometimes, and also how many questions we get asked at the end. So there's no rush to get finished for me, but I know your time is precious, and I do try and keep it down to an hour because I really do appreciate your time. Okay, so let's move on. So today we're going to try to understand UPS systems that have an internal bypass switch and what the disadvantage of that is. We're going to help you understand the need for complete isolation for electrical safety, discuss how it's possible to install a remote manual bypass switch without taking an outage on your critical loads, and discuss the advantages of an RMBs. Okay, so that's the 4 main points we're going to go over today. So on the screen here, you'll see this is the basic single line drawing for one of our systems that have an internal MBS. And what do we mean by an internal MBS? Well, what we mean by that is the actual rotary bypass switch is on the UPS itself. It's usually on the front panel, and therefore the switch is integral to the UPS unit. Okay. That is what we call an internal MBS. And remember, we say that this is a manual bypass switch. Some people interchange the term maintenance bypass switch. Manual and maintenance, the M is interchangeable. They're both the same thing. Okay. So we'll give you a reminder of how a UPS works and the power flow of the system in the different modes of operation. So you can see on the screen here, the red is the power flow and green is it's energized and ready to supply power if called upon. So we have our 3-phase AC input on the left-hand side here, usually a 480 volt supply from your MCC. That goes in, this input breaker is on our UPS, and this input transformer is inside the UPS. So this dotted line on the outside here, this shows you what is actually inside the UPS itself. That AC then goes into a rectifier battery charger, and the AC gets converted into DC. That DC keeps the batteries trickle charged, and it also supplies the DC in parallel to the inverter. And the inverter changes the DC back into AC through an output transformer, and then it goes through an output static switch, which then goes through the manual bypass switch. Now, I always want to take the time to differentiate between the static switch and the manual bypass switch. The static switch is exactly as it is drawn here. There are 2 SCRs back to back in a static switch, and it is an electronic switch that has no moving parts in it, hence the reason it is called a static switch, as in there is no movement. So we can send a signal to these SCRs, and those SCRs will switch on instantaneously, and there is no waiting time for a contact moving from one position to another. The switch switches on instantaneously, very, very quickly indeed. And the benefit of there being no movement parts is there's no arcing between the contacts. So it's a very reliable electronic switch, okay? But it is completely different from the manual bypass switch. The manual bypass switch is an actual physical rotary switch that somebody has to go and turn manually, okay? There is no automatic function on the bypass switch itself, the manual bypass switch. It has to be turned by an operator, okay? So it's a big difference between the static switch and the manual bypass switch. And then obviously we have the bypass static switch up here ready to turn on if necessary. And on the next screen, you'll see when that would happen. Well, in the next few screens. So in a UPS, one of the most common things that happens is the AC input fails. Okay, that's why the UPS is there, just in case the plant has a power outage. And then what happens in that circumstance is the battery will continue to supply power to the inverter, and that DC gets converted to AC, and the output carries on regardless, as if nothing ever happened. Okay, we're still running on the inverter because the inverter is beautiful, clean, synthetically generated AC It's a very clean sine wave and therefore very reliable. Now, the system is going to run on battery either until the power comes back on again or until the batteries get depleted. And when the batteries get depleted, then what happens is the UPS senses that we're getting down to a voltage that could damage the batteries. So the disconnect between the battery and the UPS is tripped, and that means the power going to the inverter, the DC going to the inverter, is lost, and the system will sense that. And as soon as it senses that, it sends a signal to the bypass static switch, not the manual bypass switch, the static switch. And that transfers the power to our bypass source, as you can see in that red line, through the manual bypass switch out to the critical loads. And then from that position, if you want to do work on the UPS, you can then move the manual bypass switch to the bypass position. You can see the contact has changed here, and that means power will now flow around here, down, out that way there. Okay, and that means if your AC input is off, your batteries are disconnected, then there is going to be no power going to the rectifier bridge itself and the inverter bridge itself. But you have to understand that with a manual bypass switch that is on the UPS itself, it is mounted on the UPS, you will always have power on the terminals that connect the bypass inside the UPS enclosure. And you will always have power on the output terminals inside the UPS. And you will also have power on the manual bypass switch contacts inside the UPS. So in this circumstance, yes, the main parts of the UPS are volt-free, but the whole cabinet itself is not volt-free. And that causes issues when you're trying to work electrically safe. Hopefully that is clear. So this isn't a single line. This is more of a wiring diagram for one of our UPSs, but it's the same thing again. And what we're saying here is that the 480 is off, and if we disconnect the battery, wires 110 and 15 are hot, and wires 199 to 15 are hot. And as you can see, this hashed line on the output here, these terminals are inside the UPS. So there are going to be hot terminals inside this UPS. So it's not going to be safe to do invasive work on there unless you can put an electric blanket safely over these terminals. And that's written into the permit to work system. So hopefully that explained an internal maintenance bypass switch. So what are the electrical the implications of that? Well, OSHA states that a proper lockout, tagout, or a lotto practices and procedures should be used to safeguard workers from hazardous energy releases. And the control of hazardous energy standard is 29 CFR 1910.147 for general industry, and it outlines measures for controlling different types of hazardous energy. And obviously, lotto is the standard that everybody uses. And if you go down to 1910.147, you should have an energy control program. And it is an employer's responsibility to make sure you have a program in place that protects people from unexpected energizing startup or release of stored energy. So obviously, if there is anything that is energized inside that system, you have to be able to protect and show that you have protected your employees from the energy sources, if possible. And also interestingly, in 1910.147C2, it states that after January 2nd, 1990, whenever there is a replacement of a major repair, renovation, or modification of a machine or equipment, then the new machine or any equipment installed should have an energy isolating device that can be locked out and can make that system fault-free. Now, obviously, that's open to interpretation in some respects, but basically what it's saying is you should be able to completely isolate your UPS after 1990. And the only way that you can do that is by having a remote maintenance bypass switch, or a bypass switch outside of your UPS system. Okay. So this is what the drawing looks like if you install an RMBS. Now, obviously, what I've done here is I've combined two drawings. We have an older type UPS that has an internal bypass switch here, and we have added an RMBS cabinet, which is external to the UPS. Okay, usually mounted on a wall somewhere in the same room. But what you can see here is, if we isolate the AC input at the MCC, if we isolate the battery input at the batteries themselves or at a disconnect outside of the UPS cabinet, and we use our RMBS cabinet to go into bypass, you can see here that bypass would flow here. And you can see this contact here is open. This contact here is open. That makes these terminals volt-free. These terminals volt-free, which then makes the terminals inside the UPS volt-free. So now we have isolated all power from the UPS cabinet itself, and a technician can go in and do intrusive work on this UPS, safe in the knowledge that it is locked out, tagged out, and there is no energy or stored energy inside this UPS now. Obviously, you'd have to wait for the DC capacitors to discharge themselves. We have self-discharging resistors on our DC capacitors, and that takes about 2 minutes, 2 to 5 minutes. But now you can go in and work. You can replace a whole inverter bridge if you wanted to. You could replace the SCRs in the charger. You could replace the SCRs in the static switch. You could do what you needed to do. And in truth, what you can actually do is disconnect this cable here, all the input cables and the battery cables, and you could remove the UPS if it's an old UPS, and then you could install a new UPS and then reconnect all those cables, and then eventually, using the RMBS cabinet, power the load back from the UPS. So during all of this, the loads are still being fed from our bypass source here out to our AC output. So the plant does not need to take an outage to do that, which is absolutely fantastic. But everybody says, well, I don't have an RMBS and I have a UPS with an internal bypass switch. How do I install an RMBS cabinet without taking an outage on my critical loads? And there is a way that you can do that. And that's what the next slides are going to be, is how do we install an RMBS into a system that only has an internal maintenance bypass switch while the UPS critical loads are still live. In other words, you're in a situation where you have to install an RMBS, but you can't take an outage on your critical loads. Okay, so this drawing here shows you exactly what that system would look like. Once again, we have our internal bypass switch here. We have our 3-phase AC coming in. We have our batteries here. And then on the right-hand side, we have our bypass supply. And that usually comes from an MCC at 480, and then it gets stepped down to 120 for most of our industrial UPSs that we use. Now, yes, it can be 208, 120, 3-phase, but that would just complicate these drawings if I did that. So, but most of the stuff that we do is 120 volt, single phase, okay? What I've done is I've drawn an AC panel here. This is usually what is connected on the output of a UPS system. There's an AC panel which then distributes all of the UPS backed up AC to load circuits. Now, I've only drawn one load circuit on this AC panel, but that's just for ease of viewing this drawing. There's usually going to be multiple loads connected onto that AC panel. And then also remember, this is the main AC input breaker to that AC panel, okay? So before we even replacing installing a remote manual bypass switch. We need to know how much current is flowing from the UPS into the AC panel. Okay. So let's say this is a, well, it says it's a 5 kVA system. So a 5 kVA system, it's usually going to be, what's that, about 40 amps is the expectation, full load current. But we all know that no UPS is loaded to its full capacity usually. So let's say there is 20 amps measured with our amp clamp. Okay, it's very important we know that for 2 reasons. First of all, on the next screen, you're going to see we're going to install a temporary backfeed breaker. And later on, we're going to make sure that when we do go over to that backfeed breaker, that all of the load is on there before we open this breaker here. It will become self-explanatory as we move on. Okay, so first things first, we need to know how much current is in there and then write it down so you know that you have that available. Okay, then what we need to do is get your electrical department to install a spare breaker in the AC panel that is rated to carry that full load current that you just measured. So we said 20 amps. Obviously, you're not going to put a 20 amp breaker in there. So I would say anything about 30 amps or above for a 5 kVA system would be adequate. Okay. So this is just the prep work that you need to do before you get going. And then what we need to do is install a temporary transformer. Now I say is if required. And the reason I say if required, because on the majority of systems, the MCC is feeding 480 volts single phase into a bypass transformer, and that gets stepped down to 120. In very rare occasions, this transformer isn't needed because they're taking 120 volts directly from an MCC, if that's possible. But what we see most of the time is there is a bypass transformer. And what we need to do is we need to make sure that the power that we are supplying into this spare breaker here is exactly the same as this voltage here. Now, with a single phase transformer, there is no phase shift. So as long as we know, so this is A phase and this is B phase, let's just say, we need to go to the same MCC and we need to pick off A phase with respect to B phase there. Put it into our temporary transformer, and therefore we're going to get 120 volts out here, and they should be, this one here should be in phase with this one here. But I'm going to show you how to check that before we go any further. Okay. Hope everybody's following along. Let me take a drink while you take everything I've said in. Okay, so now remember, everything that we've done previously is with the UPS on inverted to load. Everything was running as normal. So now we have to follow the procedure on the UPS to transfer to manual bypass. Okay, now on the UPS, you just follow the placard that's on the front of the UPS and follow the procedures there. There will be a procedure. One step of the procedure will be put the static switch in bypass to load, and then the last thing will be to put the manual bypass switch in bypass to load. So once you do that, you will have power flowing from here down here and then out to your UPS loads. Okay, so the UPS is now in manual bypass. So now what we need to do is make sure that we have 120 volts on this side of the breaker, on the back feed side of the breaker. We need to make sure we have 120 volts there. And then, because we're going to have 120 volts on this side coming from this bypass output here, we need to make sure with a fluke or any other multimeter that we measure phase to phase here on the same phase across that breaker, and we're trying to make sure that there is no voltage difference. between those 2 points, because they should be nearly identical, and obviously do it on the neutral as well. Now, do bear in mind that obviously I don't know what the voltages on your plant are going to be, and it could well be that your bypass transformer is 124 volts and this temporary transformer is 121 volts. Okay, so that means there's 124 on this side, 121 on that side, so that voltage reading could be 3 volts. But what I would say is, as long as it's not more than 10 volts, you should be okay. And the most important thing is it should be steady. Okay, that means that they're in sync. It should be absolutely rock solid, steady. Because what can happen is if you chose B phase and C phase here and A phase and B phase here, there is going to be a phase difference. And you would have 120, we said 124 there, you're going to have 121 volts there, but they're going to be completely out of phase. So you could, let's say, have 180 volts difference across that breaker there. And if you see that, obviously, you know you're not going to close this breaker in. Okay, so just take your time and follow this procedure when you're going through. And this ensures that you're going to maintain the load circuits when we go through the next steps. So once we've done all the voltage checks and everything's, everything's good, we can now close this breaker and we can start to feed power back through this breaker out to the UPS loads here. Okay, now at this point here, they are going to be in parallel. So the bypass transformer and the temporary transformer are now going to be in parallel, and that's okay. There's no issue with that as long as we've done all of our checks. The next thing we need to do is make sure, using an amp clamp on this cable here, that we are actually supplying current through that breaker. That proves that this temporary transformer has taken some of the load, which means this breaker has closed correctly. And it's just allowing us to know that we can open this breaker here without any issues, because we have seen current flowing through here. We're just double checking, triple checking everything to make sure our critical loads are maintained. So we've done all of our checks. We've seen that there is current. So what we can do is we can open the main AC input breaker to the AC panel, okay, because we've checked that there was current. And as soon as you do that, then once again, we take an amp clamp and we go on here. And if anybody was paying attention to what we were doing earlier, remember we said there was 20 amps going through the main breaker. So now we should have 20 amps going through this breaker. And that way we know that we have maintained power to all of the critical loads. And once we see that, what we can do is we can disconnect or open, lock out, tag out the main bypass supply bucket that feeds the UPS. And then what you can see is we will have no AC input here. We've disconnected the batteries and locked and tagged them out. And now we have no power here, and we have opened this breaker, so we have no power here. So all of the terminals going to this UPS are now isolated, locked out and tagged out, and electrically safe. Okay. And that's just what this screen says again. So now what we can do is we can install the remote manual bypass switch cabinet, okay? And hopefully you have done your pre-planning and you've already mounted it to the wall. You've already ran the conduit between the RMBs cabinet and the UPS cabinet in preparation for connecting it. The important thing is that when you install the RMBs, we want the switch to be in the isolated bypass position, which is position number 3, okay, which means this contact here is open. You can see that says 1 and 2, that says 1. This one here says 3, so that is the only contact that's closed, because that means that we're going to have no power at these points here, okay? And another important thing that we always recommend to do is, I don't know why my screen is showing that line missing there. It's weird, but on the bypass switch that's internal to the UPS, what we always recommend now is you put that in the normal position, and then you unscrew the handle and you take the handle off, because from now on, that switch, we're going to treat it as if that switch is not even there anymore. There's no need for you ever really to switch that switch anymore, because we've got the switch external to the system. So we always recommend that you remove the handle so misoperation cannot be performed. Okay. So, and as you can see here, we still have the bypass isolated to the UPS. And the other thing that I want to show you is what we tend to do within AMETEK solid state controls is we try and keep the wire numbers the same. So you can see here that you should connect 110, terminal 110 in the RMBs cabinet to terminal 110 in the UPS. 15 is neutral. And then the output of the UPS is 199. That should be connected to 199 in the UPS. Obviously, 15 is neutral. The only thing that we don't know is what you've called your wire numbers going from the bypass transformer here into your UPS. But your bypass source input should be connected to 800. And then the output of your RMBs to your critical loads should be connected to 810 and 15. Okay. So now what you can do is remove the lotto from the UPS bypass at the MCC. So we can now energize the 480 volts. That will allow power to go down here through that contact and back out here. Remember, this breaker is still open and we are feeding the load circuits through this way here. But now we're getting ready to go back to normal operation. All the wires have been connected and everything is good. And our RMBs is still in position 3. Now we move the RMBs, the remote manual bypass switch handle, to position 2. And as you can see here, position 2 there and position 2 there. There is no position 2 here, so that remains open. So this one here closes, this one here closes. And that allows power back into our UPS cabinet up to the bypass input breaker. So that's preparing us to be able to turn the UPS on and do some testing. We've still got this AC breaker, the main AC panel breaker open, okay? Then we remove the lotto from the AC input. Here we remove that lotto and we remove that lotto, and that means we have AC available at the charger and DC available at the battery. And then we follow the procedure to start up the UPS, okay? So we energize the UPS, the charger is now on, the inverter is now on, and we have power going to the static switch. Once again, I don't know why that line's disappeared because it's actually on my presentation. So we do have power going there, but we're in the bypass to load on the static switch, remember, because remember this switch is always going to be closed here on UPS. So we have voltage going to that contact there in the RMBs cabinet, but it is still in the open position. What that allows us to do is that allows us to test the operation of the static switch inside the UPS. So we can actually turn this static switch on and supply power to there, and we can transfer it from inverter to load, bypass to load, and make sure the transfers are okay before we say, okay, everything looks good. Our UPS is now back in full operation. And then what we do is return. We have to do this, return the static switch to bypass. So we have to return the static switch. Remember, that's the switch that doesn't move. It's the electronic switch that's operated by a push button on the front of the UPS. We turn that to bypass. Sorry, we press the button that says bypass to load. That is essential for these next steps. Then we do what we did earlier on this input breaker, the backfeed breaker. We're going to do the same checks on the main breaker now. We're going to check we have 120 volts line to neutral. And then we are going to check across the contacts of this breaker because it's open and we want to see 0 volts. Obviously, I mentioned earlier, it could be as high as 10 volts, but we want to make sure that it is a steady voltage and that it's not more than 10 volts. Okay, so we've done our checks. Everything looks good. The next step is to close this main AC breaker. So now we're feeding power from the bypass transformer back down out through the UPS loads. But remember, still in parallel with the temporary transformer. Okay, I hope that makes sense. And once again, we take an amp clamp and we want to see current flowing through this breaker. Now, here's a confusing thing. Remember, this transformer and this transformer are now operating in parallel. You may not see the full 20 amps at this point. You know, it's depending on the voltages and the length of the cable drops and all that kind of stuff. You could see 10 amps here and you could see 10 amps here. But really what you're checking for is to make sure there is current flowing through that breaker to make sure that it did actually close. And then once we've checked that there is current, we can open that breaker with confidence because we now know that this is going to feed your critical loads. The last thing we do is take the amp clamp. What should we have at that position here? We should now have the full load current of 20 amps. Just double checking absolutely everything to make sure we are doing things correctly. Okay. So now we are pretty much back to normal. Our backfeed breaker, that should say, is open. I missed that one. This one here should say closed. We are now back in normal operation, and all we need to do now is get the UPS onto inverter to load. And to do that, we move the RMBs to the normal position first. Normal position here is position 1. Okay, normal operation. The only contact that closes is this one here, position 1. This one here was closed at position 2 and remains closed at position 1. So now power is flowing down this way here through the static switch, which is still in bypass. Okay. And then the last thing we do is we press the inverter to load push button on the UPS, which will tell this static switch here to turn on. And therefore, we're going to supply power as we should be through the UPS, through the RMBs, through the AC panel, that closed main input breaker, out to our UPS loads here. So now we are back in complete battery backed up normal operation. And we've done this without losing power to the UPS critical loads. And you now have an external RMBs that will allow you to go in and do maintenance on this UPS cabinet whenever you need to do so. And you can lock out, tag out all of the power supplies, and you can work on it safely. Okay. And then the last thing we do is remove the temporary power supply, remove the transformer and the wires that go back to the MCC. Okay, and you can remove the spare breaker if absolutely necessary. So hopefully that, I know it's a complex thing to get your head around, but you can go back and watch this later and get a better understanding of what I said. And once again, I'm going to go over the advantages of that RMBs now. Basically, we can go to the isolated bypass position, position number 3 on this UPS, on the RMBs, sorry, position number 3 there, that means power flows down through this way here. And that means this is volt-free. This is volt-free. This is volt-free. This is volt-free. If you turn off the battery and you turn off the MCC, that means everything inside this UPS cabinet is volt-free, and OSHA and NFPA 70E says you are good to go in that UPS, replace capacitors, replace IGBTs, replace SCRs. In truth, replace the whole UPS cabinet if you really, really needed to. If you had an old UPS and you wanted to install a new one, you can go ahead and do that now when you have an RMBS. It gives you that flexibility and the safety to know that you can do that without any electrical energy inside this UPS whatsoever. And the last thing I want to touch on is, well, a lot of people say, well, when you're on bypass, you don't have any battery backup. So yes, we can keep these UPS loads powered, but we're kind of in a bad situation where if we have a power failure in the plant during the installation of this RMBS cabinet, then we could have a power outage to our UPS loads. Well, there's a way to get around that. It's a little bit more expensive way to get around it, because what you need to do is, instead of just installing a temporary transformer, what you can do is actually install a temporary UPS to backfeed the system. And if you do that, this temporary UPS is going to have its own battery. So you are going to feed power to your UPS loads this way. And if you do have a power outage while you are installing this RMBS cabinet, then this temporary UPS will sustain power during the outage to allow you to do whatever you need to do. So yes, you probably do have to pay extra to get a rental UPS from a UPS company to be able to do that. And obviously there's more wiring and more expense. But this is what I call the belts and suspenders way of doing it. This way you know that you can do the replacement without any issues whatsoever if you install a temporary UPS to backfeed the AC panel. The procedure is exactly the same, whichever way you do it, but it is a good way to install an RMBS with remaining on a UPS backup to your load circuits. Okay, so that is everything I have to discuss on an RMBS, how the advantages of the RMBS, and the electrical implications of the RMBS, and obviously how to do it with your load circuits still being supplied. And another question that people ask is, do we have, let's say you have a different manufacturer of UPS. Can we install an AMETEK SCI RMBS onto our other manufactured UPS? Yes, you can. The RMBS really doesn't have any logic controls that go to the UPS itself. You can have some auxiliary contacts that tells the UPS what position the RMBS handle is in, but that's not necessary. In truth, just for being able to isolate the UPS, you can use an AMETEK solid-state controls RMBS on a different model of UPS, as long as it matches the kVA rating and the output voltage rating. There is no proprietary connections that need to be done with our remote maintenance bypass switch. So it's very, very flexible to allow plants to do what they need to do. Okay. So now I open it up to any questions. Now, obviously, I prefer that the questions were about what we discussed today, but I'm here until 1 o'clock. Until 11 o'clock Central Time. And if you have any other questions whatsoever regarding UPSs that you would like to ask, then I will try my best to answer them. We have a question from Norik. How does the EMI REFI based on EPRI guidelines affects dimensions of a UPS? Norik, I have to admit, I do not know the answer to that question, but I do download all of the questions and I will mark that one as something that I don't know, and I will get our engineering team to email you back. Also, how are the AC cables protected? The AC cables are always protected by the breakers. So the breaker on the UPS will have a high current trip setting on it, and that is what protects the cable between the UPS itself and the AC panel that it gets connected to. If there is a short circuit, then that AC output breaker should trip. Okay, hopefully that answers your question. Do we also have two-phase RMBSs? Yes, we do. We can have 240 split-phase RMBSs, three-phase RMBSs. We can do whatever you need us to do. Norwich saying the first slide. Unfortunately, the way that Webinar Jam works is I have to go page by page by page. Okay, another question we've been asked is, is an RMBS reliable? And the answer to that question is yes. The cam switch in those bypass switches are very reliable, but there is a caveat to that. The manufacturer recommends that they are exercised on a regular basis, basically at least once a year, because with all contacts in any switch, there is usually a wiping mechanism when you go from one position to another position that wipes the contacts clear of any oxidization or anything that could get onto those contacts. So they are very reliable, but I will say if I went up to any switch that hadn't been operated for 10 years, then I would be very dubious whether that switch is going to work correctly. And would you be able to perform maintenance on an RMBS? In truth, there's only a switch in the RMBS, so there's really not that much maintenance that needs to be performed. We do have a sync board inside our RMBS that tells you that the system is in synchronization, but the way that it is designed is it's accessible without having to go into the main terminals. So it is easy to work on and they are reliable. So hopefully that answers your questions. What are the experiences with two-pole electronic static switches for floating systems? It's a very good question, Janet. I would have to see. You do have my email address, so if you want to send me the diagram of the system that you're talking about, then I could look into it more and get back to you. It depends on whether they're switching the neutral and what's going on. Usually with static switches, they're just switching the live on each pole. So on a floating system, it really shouldn't make a difference. I can't see why it would make a difference. But once again, I would have to see the whole system drawing to see if there's anything there that I may not be thinking about. So please send that drawing to me. It would be appreciated. Okay, so I'm back on the first drawing here. So the first slide, how do... okay, you're absolutely correct on this first slide here. This is a single line drawing and there isn't a breaker drawn here. How is the cable protected? There is going to be a fuse internal to the system, and that fuse should blow. So that should protect the cable, because there is no current protection on the RMBs. So if we're on inverter, actually in truth the fuse is there. If we're on inverter, that fuse would blow. If we're on bypass, this breaker here would trip. So we do have protection on the cable, either through this fuse here, or if we're in bypass, it would be on that breaker. Good questions though, I like that. If no temporary transformer, can you use existing bypass transformer? Very, very good question. And when I started doing this presentation, that is the way that I was going to draw it. But there is a problem with that. And let me go to where that problem is. Here. Okay. So what the question is asking is, can we tap off here? Actually, let's go to the next slide. There. So can we tap off here and go down and connect that there on the hot, and tap off there and go down to there? The problem with that is, if you remember, let's go to the drawing that tells us. And it should be the next slide. Yep, the next slide here. At this point here, we have isolated. We have to isolate this because we are going to remove these cables. So if we've used the hot to go down here and the neutral down here, okay, when we isolate this, we are going to isolate the power going to the UPS loads. So once you get to this point here, you're going to drop the load here if you tapped off the original bypass transformer. If you had a breaker here, yes, you could do that. And there are some installations where there is a bypass breaker between the bypass transformer and the terminals on the UPS. So if you did have that, then yes, you could tap off the output of this transformer, open this, and that isolates these 2 points here, and you still have power going down to the loads. So it's a very, very good question. But yes, you can only use the existing transformer if you have that output breaker. Okay. Another question, how many AC panels can be connected to the output cable of a UPS? That is completely up to you. And you just have to stay within the rating of the UPS. So if it's in this drawing here, it's a 5 kVA UPS. So you can put 10 panels on there, but that means you can only have, each panel can only supply half a kVA, because all of the panels would add up to 5 kVA. Or you could have 5 panels, one could be 4 kVA and the other's 0.1 kVA. You've just got to, there is no restriction on how many panels can be connected. It would just get cumbersome on trying to mount all of those cables into the UPS terminals. So there is no limit as long as you stay within the rating of the UPS. Really enjoying these questions today. Very good questions. Any more questions before we say goodbye? I'll give it a few more minutes. As I mentioned earlier, this webinar is going to be recorded and put on our YouTube channel. So our marketing team is going to post the link to the YouTube channel in the chat bar. So you can copy that and you can use that. All of our previous webinars are on our YouTube channel. Thank you, Taylor, for putting that in there. So you can go and check those out. Also, after the webinar, you will receive a survey from our marketing department. And please don't treat it as an annoying survey and us fishing for compliments. That's not the reason of the survey. What we want to know, the most important question to me, and I think it's question 5 in the survey, and it asks, what would you like us to discuss next? And that's actually one of the reasons why we did RMBSs this week, was because one of the surveys came back and said they would like us to discuss how to install a remote manual bypass switch. So I went ahead and made a presentation for that. So if you have any suggestions on something that you have seen that you would like discussed in detail, then please do fill out the survey and let us know, because it really is an important part of us giving you what you need. There's no point in me spending an hour every month just talking a lot of nonsense to people when there's something specific that you want us to discuss. Hopefully that makes sense. And Taylor has also put it in there, if you need any additional assistance, you can go to our website, service at AMETEK Solidstate Controls, and you can get the telephone number, the email address, everything is on our website if you need to contact us. And the 800 number, the 1-800-635-7300 number, that is manned 24 hours a day, 365 days a year. How do we do the maintenance for the PCB control inside the RMBS? Very good question again. I will have to get back to you on that. In truth, I would assume we would go to the isolated bypass position, and that would allow us to replace that PCB. I would have to check the drawings and be absolutely clear that that PCB is then going to be volt-free, but I'm pretty sure that is the case. The isolated bypass would remove power from the PCB. Actually, maybe it doesn't. Maybe there's a lamp that's still lit when we're in the isolated bypass position. I will get back to you on that one. Very, very good question. But I promise I will get back to you on that. Okay, we just got a few more minutes left, so please type in any more questions. But at this point, I would just like to thank you for your time today. As always, I know that you are busy guys, and I know, busy guys and girls, and I know that taking an hour out of your day to do this is an hour you could be spending doing something else. So I do really appreciate you taking the time to listen and watch what we had to offer today. You have all the details you need to be able to contact us. And once I finish this webinar, I will answer any questions that remain unanswered via email. I have everybody's email that asked a question, so I will answer them via email. So it looks like we have no further questions. So we did finish within an hour. Woohoo! I don't know if that's a first, but it's pretty darn good. So enjoy the rest of your week. Stay safe. And until next month, take care, and I'll speak to you soon. Thanks very much.